Yes.
Right.
Yes.
Now, as I told you yesterday, we are first going to discuss a rigid body called thin rod.
Yes, sir.
A rigid body called thin rod, and thin rod is one of the special. I mean, is one of the special rigid bodies. Why? Because all the particles in that are arranged in a straight line. Okay. Now you see. See, you should also appreciate how the science is developing here, because science is a beautiful build. I told you know concepts. So here we are considering a rod AB, and we are marking a center of the rod as C. Okay, and then we keep the center of the rod C, and we are having a reference point O and the reference direction X. Okay, because now if I want to address the rod, okay, I should have an address for the rod. So therefore, I have chosen the center as one of the position, so that I can say with respect to O, the center of the rod is at C.
That center is geometric center.
Geometric center. Geometric center. Right. Geometric center of the rod is C. Right? Okay. Now what I do, I extend the line from A to B to intersect with the reference line X, and it is making an angle theta. Okay? Hello? Right?
Yes.
Now you can think about explaining the motion of this rod. Okay? You can explain the motion of this rod. Now, if this R bar does not change, what did I say?
This R bar does not change.
R bar does not change.
R bar does not change means what? This center of the rod will not change its position.
Yes.
While I will allow the A, B positions to change.
Yes, sir.
Then what type of motion?
Pure
Rotation.
Pure rotation motion. Pure rotation motion about the center C.
Yes.
Pure rotation motion about the center C. This is one aspect. Okay. Now you see, supposing this rod moves, that means the position of this point C will change. Okay, that the position of this point C will change. Okay, so but the angle theta will not change.
Yes, sir.
That is another way.
Yes.
Hello.
Yes, sir.
Yes, sir.
Angle theta will not change. Then what type of motion is the rod performing?
With respect to which point? Reference to.
Good point.
Combination of rotation and
Yes, with respect to this reference O, what type of motion is that?
It's having both rotational and
Translated motion.
rotation.
It is having both. It is having both. No. Theta is same. I said it will have another position C dash, and the line A dash C dash B is and when it intersects X, the angle theta will not change.
Rotation.
I hope you are able to imagine what I said.
Yes, sir.
Very simple. I said very simple. So the fact is, I told this, that is this. So the rod is like this, A, B, this point is C, and this point is O. This is of course X. So this I say is R1 bar. Okay, and this point is C. And this one, if I extend, it is making an angle theta.
Yes, sir.
Now the next position of the rod is such that next position of the rod means B will be occupied at B dash, okay, and A will be occupied at A dash, C will be occupied here, okay. So this will be C dash, A dash, B dash, and this angle will still be theta, but this one will now become what? R2.
Yes.
Yes. Now what type of motion is the rod making?
Pure rotational
Rotational and
translation.
Okay. Now cool. Now cool. See, now here, why are you telling it is rotational and translation?
Like when you take reference points, no, sir. When you draw the position vectors, the angle theta is not same.
So angle. See, now here I have specified this angle theta.
That kind of theta will be same. But if you are taking that O as the fixed point,
Huh.
that time the theta which is found for the position vectors at C and C at two different displacements, no, sir. That theta 1 and theta 2 will not be same, sir.
Right.
So it is performing both rotational as well as translation with respect to the point A.
Yes. Do you all agree for that?
Yes, sir. Yes, sir.
Fine. Huh. In this context, with respect to reference O, it is performing both.
Yes.
It is performing
Yes.
both. There is no doubt about this. Okay? But then there is one more situation where the rod is like this, and now the rod is like this. So this is theta 1, and now this is theta 2. Right? And this is C, and this is this. Now what type of motion is this?
Rotation. Yeah, only. But which reference points? Right?
So again O. I have
Again,
only shown O.
We will-
I have shown O. Think it over, all of you.
Sir,
Hmm.
sir, can you draw the bigger circuit diagram a bit bigger? Sir? It's
Why, man?
very small.
Everybody
It's
is.
looking very small on the screens.
Is it so? Hello?
Oh, sir, it's fine.
You are watching on the computer or a mobile phone? Hello?
Sir, phones.
Then what can I do, gentlemen? See, these classes you should not watch on phone. It is not meant for that. If you are not serious, what can I do? You tell. And all these days, if you are doing like that, God save you.
No,
Phone.
sir, only today, sir. Laptop is first.
See. Is that okay?
Yes, sir, fine.
So this is theta 1, this is theta 2. So this was 1, and now this one. After that. Okay, what type of motion is this?
Rotational and translation.
Combination of yes, sir.
Rotational and
Yes, sir. Rotation.
translational and rotational about fixed point and fixed point both.
Only, I am not giving you any reference point, only one reference point I got.
That's set up for.
And then what is the difference between this motion and this motion?
Here it's not anything about the.
No, you aram se tell, think aram se and give me the answer.
One minute, sir.
Sir, in first case, sir, about C there is no rotation, sir, but in second case there is additional rotation about C also.
That is a good observation.
Yes, and even the.
That is a good observation. That is a good observation. That's what I wanted you to observe.
Yes, sir.
That observation is important.
Yes, sir.
So, in the first case, it is not rotating about the point C.
Yes, sir.
But with respect to O, it is rotating and translating.
Yes, sir.
So, in the
Yes,
second
yes.
case, yes,
Yes, sir.
the rod, as a matter of fact, is translating and also rotating with respect to O. But with respect to a fixed point in the rod, it is, in the first case, it is not rotating. In the second case, it is rotating about the fixed.
Fixed point. Yes, sir. And even one more thing.
Huh.
R1 and R2, they are two position vectors now, sir.
Huh.
Yesterday, what we did using the triangular law of vector addition, sir. The unit.
No, wait. See, there you were discussing the points,
Point.
particle. Here we are discussing the whole group of particles.
Oh, yes, sir.
There is a difference.
Yes, sir.
The concept there is different, the concept here is different. So you should not mistake.
Yes, sir. Okay.
You should not mistake. Now for a group, what it will see, for a rod, how it behaves. For a only particle, how it behaves.
Yes, sir.
Now you understand this, then you will understand how it behaves for a body.
Oh, yes, sir.
We'll go into it.
Yes.
Okay? Yeah, cool and calm, you get these basics right. Okay, then wonderful, you will do a lot of other things. Okay, so this is it. Now, well, this diagram is familiar to all of you. That is, you see here, it is rectilinear translation. Here the rod is performing curvilinear translation. Okay. So second case is curvilinear. I think this was something which was discussed yesterday also. I showed this diagram yesterday.
Yes, sir.
See, both are pure translations.
Come on, yaar. Right now I told, where are you? I told this is rectilinear translation and this is curvilinear translation.
Both are pure translations.
Why are you confused? Why are you using that word here? See, we are discussing rod.
Yes, sir. Rod.
Rod. We are discussing rod. See, we
Yes,
use
sir.
the word pure translation in the case of a particle only.
Say for rod and pure translation.
Okay, yes. For the rod also now it is pure translation. Correct.
Both cases.
Both the cases. There is no doubt about it.
Okay.
No doubt about it. See, when I said rectilinear translation and curvilinear translation, the word translation has come there. Now don't add one more adjective there and say, okay, pure and Yeah. Pure
translation. If the rod is
moves in a plane such that it always makes an angle theta with OH, the motion is called pure translation.
yes, then only the rectilinear translation motion is pure. No, both are.
Both are pure
Both
translation.
both.
Okay. But both are pure. But only thing is, I am making a distinction here.
Yes, sir.
Because the lines here are parallel, the lines here are curved. So
Yes,
it becomes curvilinear.
Yes.
Okay. So this